Hello. All right, in this video we're going to talk about geometric transformations, specifically the transformation called the dilation. This is part 2 of a 3-part series on dilations. There's a lot of information. Part 2, we're going to be focusing on dilating images. Part 1 went into more information about what a dilation is, and we worked on dilating points. Part 3, we are going to actually determine the scale factor of dilation. So like I said, part 1, we went into these pretty much in a lot more detail than we're going to do in this video. So go see part 1 if you want more detail on these. But first of all, what is a dilation? Well, a dilation means that our shape's going to change size. We're going to get bigger or smaller. It's going to keep its original shape and orientation. We're just getting bigger or smaller. One of the terms we're going to run across is something called a scale factor. Dilations deal with distances. Think dilations, di, distance, di. Dilations, distances. So they're going to say, dilate this figure about some point. Okay, cool. You've got a reference point. So now what you need to do is you need to figure out, all right, from my reference point to the point that I want to dilate, I have some x and y distance. We got to figure out what are those x, y distances and then multiply them by our scale factor. Our final sanity check after performing some dilation is we need to figure out was our image supposed to get bigger or smaller? It's supposed to get bigger if your scale factor is greater than 1. It gets smaller if your scale factor is between 0 and 1. All right, so let's go work some examples. Like I said, part 2, this is, we're going to be dilating images. If you're not sure how to dilate points yet, go back to part 1. But part 2 is just, it's dilating images. All right, so our first example, we're going to be dilating figure ABCD by a scale factor of 1/3 about the origin. There we go. There's our point of reference. So the origin is always the point 0, 0. I'm going to put a dot there, and I'm going to call that R as our reference point. Now all of these distances that we're about to find that we're going to scale, we're going to be starting at the reference point, going to the point that we're looking at. So let's look from, we're going to have to find R to D, R to C, R to A, R to B. And we're going to have X distance, Y distance, and then we're going to have our scaled distance, which is 1/3 X, 1/3 Y. Okay, so first let's start from R to D. To get from R to D, we go 3, positive 3, and we go up 3. C, we go negative 3, up 3. A, we go 6 in the X direction, and we go up 9. B, we go negative 6 in the X direction, and up 9. Okay, so there's all our original distances from our reference point. So now we're going to scale those. So we're just going to multiply each of these by our scale factor. So we're going to have 1/3 times 3 is 1. 1/3 times 3 is 1. 1/3 times negative 3 is negative 1. 1. I'm just going to do it for all the rest of them. 2, 3, negative 2, 3. All right? So those are our scale distances now. So our dilated image, we are that much closer to actually graphing. Now we go and we graph these. So from R to D prime, we're going to go 1 to 1. So from R to D prime, R to C prime, R to A prime, and R to C prime. All right, so from R to D prime, we're going to go positive 1, up 1, C prime. C prime, we're going to go negative 1, up 1, C prime. A prime, we're going to go 2, up 3, A prime. And B prime, we're going to go negative 2, up 3, B prime. And then we're going to draw our image. And I'm freehanding this. I'm trying to make it as straight as possible, but that's a little bit more difficult on a computer screen than it is on a piece of paper. All right, so that's our new image. That is our dilated image. And as you can tell, as expected, it shrunk because 1/3 is smaller than 1. It's between 0 and 1, so it shrunk, which is what we wanted. So it's a lot smaller, considerably smaller. So let's look at the coordinate points now. A prime, B prime, C prime, D prime. A prime is at 2, 3. B prime is at -2, 3. C prime is at -1, 1. And D prime is at 1, 1. Now what's interesting about this is those coordinate points match the distance, match the scaled distances, the x's and y's. Now why is that? Well, that's because if we are rotating about the origin, it's a special case. Because any xy coordinate pair you have is just the distance in the x direction and the distance in the y direction from the origin. And that's all we were finding is distances in x, distances in y's, and scaling them. So an origin dilation is kind of a special case, but this whole point of putting that reference point and doing this table and figuring it out, scaling it accordingly, I highly recommend, because with this next example, let's look at it. This next example, we're dilating the figure by a scale factor of 2 about point A. We're not going around the origin. So we need to be able to understand that whole reference point thing that we just did. So point A is going to be our reference point. So we're going to go from A to B, A to A, because you have to look at that one too, A to D, and A to C. So the xy between A and B, well, let's look at that. All right, A, we're going 1, 2, 3. +3 in the x and nothing in the y. A to A, we don't move. 0, 0. A to D, we go -1, up 1, 2, 3, up 3. And A to C, we go 1, 2, 3 in the x and 1, 2, 3 in the y. Okay? So we have found our originals at this point. These are our original xy distances. So now we're going to scale it. Scale factor of 2. What do we do with those distances? We multiply them by our scale factor. So to get from A to B prime, we're going to multiply everything by 2. So 2 times x is 6. 2 times 0 is 0. A to A. We can't go anywhere to get from A to A. So 2 times 0, 0. 2 times 0, 0. A prime and A are going to stay exactly in the same spot. Okay? A to D. 2 times -1, -2. 2 times 3, 6. This is A to D prime. And A to C. 2 times 3, 6. 2 times 3, 6. A to C prime. And now we graph it. All right? So from A to B, we were 3, 0. Now we want to go 6, 0. So 1, 2, 3, 4, 5, 6. B prime. Okay? A to A, we're not changing. A prime is going to stay right there. A to D. Okay, we need to go -2 now. 1, 2, 1, 2, 3, 4, 5, 6. This is D prime. And C prime is going to be 6, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. C prime. And then we draw our image. Again, freehanding it. Give me a little bit of leeway, please. So, when we're dilating about a point that's on the shape, that point isn't going to move, just like A. A did not move because we were dilating about point A. But everything else got dilated by a factor of 2. So our image did get twice as large. And we did expect it to get bigger because 2 is bigger than 1. So then they just want to know what are the coordinates. So remember when we went about the origin, the coordinates were just the new distances. That's not how this one's going to work. This one, the coordinates, we have A prime at -5, 1, which it did not change, B prime at 1, 1, C prime at 1, 7, and D prime at -7, 7. Right. So this is dilating images. This is part 2. Remember, tune into part 3 for actually determining scale factors. So in the next video, they're going to give you the 2 images and ask what was the scale factor of dilation. So we're going to go over how to figure that out. If you have more questions, please subscribe to my YouTube channel. If you have any specific questions, please visit my website, go to the contact page, and submit your question via the submission form, and I'll be happy to answer. Thank you for watching.